In this video, we are going to calculate the empirical and molecular formula of organic compounds. How do you determine the empirical and molecular formula of organic compounds? So let's say you have an organic compound here. So this is the compound. We don't know what it is made up of, but we know that there is carbon, hydrogen, and oxygen inside the compound. What you do is that you heat the compound in XX oxygen. When you do this, you convert all the carbon in the compound into carbon dioxide, and then all the hydrogen into water. So when you get the carbon dioxide in the water, the way to know the mass of the carbon present in the compound is by passing the carbon dioxide gas through sodium hydroxide in a tube. When you do that, the sodium hydroxide will absorb the carbon dioxide, and therefore the tube will increase in mass. So you'll be able to calculate the mass of the carbon dioxide passing through the tube. And having known the mass of the carbon dioxide and then the mass of the compound, you can determine the percentage composition of carbon in the compound. It is the same for water. For the water, you pass the water through magnesium perchlorate. When you pass the water through magnesium perchlorate, the magnesium perchlorate will absorb all the water. And when it absorbs all the water, it will also increase in mass. So we'll be able to determine the mass of the gaseous water passing through the tube. And with the mass of the water, we can determine the mass of the hydrogen. So using this understanding, let's use it to solve the following questions. 3.42 milligrams of an organic compound yielded 5.2 milligrams of carbon dioxide and 1.98 milligrams of water. No other elements were detected. Determine its empirical formula. So, from the question, the mass of the compound was given as 3.42 milligrams. And then the mass of carbon dioxide is also given as 5.2 milligrams. And the mass of water, H2O, is given as 1.98 milligrams. So the first thing we need to do is to find the mass of carbon present in the compound. And then that one is equal to the atomic mass of carbon dioxide, which is 12, divided by the molar mass of carbon dioxide, and that is 44, times the mass of carbon dioxide present, and that is 5.2 milligrams. And this is equal to 1.42 milligrams. So this is the mass of carbon present. So we need to find the percentage of carbon present, and that is equal to the mass that we got for carbon, which is 1.42 milligrams, divided by the mass of the compound. And the mass of the compound is given as 3.42 milligrams, and then times 100%. And then this is equal to 41.52%. Now, the next thing we need to do is to find the mass of the hydrogen present, and that is equal to the atomic mass of hydrogen. Atomic mass for hydrogen is 1. However, there are 2 hydrogens present in water, so that will give us 2 divided by that molar mass of water, that is 18, times the mass of water that was detected in the compound, and that is 1.98 milligrams. So the mass of the hydrogen is 0.22 milligrams. So here is milligrams, and then this place too is also milligrams. So we need to find the percentage of hydrogen that is present. So that is equal to 0.22 milligrams divided by the mass of the compound, and the mass of the compound is 3.42 milligrams. So in this case too, it's milligrams divided by milligrams, then times 100%. and this is equal to 6.43%. So, how then do we find the percentage of oxygen present in the compound? It's going to be 100% minus the percentage of carbon, which is 41.52%, then plus the percentage of hydrogen, which is 6.43%. And when you do the subtraction, you are going to get 52.05%. So at the end of the day, we need to write down the various elements, which is carbon, hydrogen, and oxygen. Now, the percentage composition of carbon is 41.52%. And then for hydrogen, it is 6.43%. And then oxygen is 52.05%. Then the next thing we will do is take each of the percentages and divide it by their atomic masses. So in the case of carbon, it is 41.52 divided by 12. And then hydrogen is 6.43 divided by 1. And oxygen is 52.05 divided by 16. So if you do this division, 41.52 divided by 12 is 3.46. And then here 6.43. And then 52.05 divided by 16. That is 3.25. And the next thing is you take the smallest among the three and then divide through each of them by the smallest. So in this case, the smallest is 3.25. So here will be 3.25 divided by 3.25. And here is 6.43 divided by 3.25. And this place is 3.46 divided by 3.25. So 3.46 divided by 3.25 is about 1.06. Then 6.43 divided by 3.25 is around 1.98. And then here is 1. So if we round it off to the nearest whole number, here is going to give us 1. This place will give us 2. And here will give us 1. What this means is that there is 1 carbon present in the compound. Hydrogens are 2. And then oxygen. So this then becomes the empirical formula here of the organic compound. So rounding it off, so I think I made a mistake. Rounding it off will give us 1 and then 2, 1. So this is carbon, hydrogen, and oxygen. Caproic acid, the substance responsible for dirty gem socks, contains carbon, hydrogen, and oxygen on combustion analysis. 0.45 grams of sample 0.45 grams sample of caproic acid gives 0.418 grams of water and 1.023 grams of carbon dioxide. What is the empirical formula of caproic acid? If the molar mass is 116.2 grams per mole, deduce the molecular formula. The mass of the sample is given as 0.45 grams. And the mass of carbon dioxide that was obtained is given as 1.023 grams. And then the mass of the water, H2O, is given as 0.418 grams. So what we will do is that we need to find the mass of carbon present, and that is equal to the atomic mass of carbon divided by the molar mass of carbon dioxide times the mass of carbon dioxide that was obtained, and in this case it is 1.023 grams. So this is equal to 0.279 grams. So this is grams. Then we need to find the percentage composition of carbon, and that is equal to the mass of carbon that was obtained, 0.279, divided by the mass of the sample, and that is 0.45 grams times 100%. And this is equal to 62%. And then let's also find mass of hydrogen present. So that is equal to the atomic mass of hydrogen, which is 1 times 2, and that will give us 2, divided by the molar mass of water, and that is 18, times the mass of water that was obtained, and that is 0.418 grams. And this is equal to 0.0464 grams. So let's find the percentage of hydrogen present in a sample. And that is equal to the mass of hydrogen, which is 0.0464 grams, divided by 0.45 grams times 100%. And this is equal to 10.3%. So the next thing we need to do is to find the percentage of oxygen in the sample, and that is 100% minus the percentage of carbon and hydrogen in the sample. We got carbon as 62% plus water is 10.3%. So this is equal to 27.7%. So having gotten this, we can then find the empirical formula. So carbon, hydrogen, and then oxygen here. The percentage composition of carbon is 62%. So carbon is 62%, and then hydrogen is 10.3%, and then oxygen is 27.7%. So take each of them and then divide by their atomic masses. So in the case of carbon, is 62 divided by 12, and that is equal to 5.167. And then in the case of hydrogen, it is 10.3 divided by 1. That will give us 10.3. And then oxygen is 27.7 divided by 16. And that is equal to 1.7. So if we look through, the smallest here is 1.7. So here is 1.7 divided by 1.7, 10.3 divided by 1.7, then 5.167 divided by 1.7. So here is 1, and this place is 6.05, and 5.167 divided by 1.7 is 3.04. So if you round it up to the nearest whole numbers, then here is 3, then here is 6, and this is 1. What it means is that the empirical formula for caproic acid is C3H6, and then oxygen is 1O. So this is the empirical formula of caproic acid. However, the question says we should find the molecular formula, but they give us a molar mass of 116.2 grams per mole. But we know that the empirical formula C3H6O times a certain number n will give us the molar mass, which is 116.2 grams per mole. So let's find the value of n. So the atomic mass of carbon is 12, so 12 times 3 plus 1 times 6 plus 16, so here 16, then times n is equal to 116.2 gram per mole. So 12 times 3 is 36, plus 1 times 6 is 6 plus 16. All of this times n is equal to 116.2. If you sum of 36 plus 6 plus 16 is 58, n equals 116.2. So you divide through by 58 and divide here too by 58. So this one and this one will cancel. So n is equal to 116.2 divided by 58 is equal to 2. So therefore, the molecular formula for caproic acid is equal to C3H6O. Then n is 2, so times 2. And therefore, the molecular formula is equal to 3 times 2 is 6, so it will be 6. 6 times 2 is 12, H12. And then 1 times 2 is 2, so O2. Determine the empirical formula of monosodium glutamate, which contains 35.51% carbon, 4.77% hydrogen, 37.8% oxygen, 8.29% nitrogen, and 13.6% sodium, with molar mass 169 gram per mole. So the various elements are carbon, hydrogen, oxygen, nitrogen, and sodium. So the percentage composition. So let's write their percentage compositions. Carbon is 35.51. Hydrogen is 4.77%. So this is okay. And then oxygen is 37.85%. Then nitrogen is 8.29%. Then sodium is 13.6%. So you will divide each of them by their various atomic masses. So in the case of carbon, it is 35.51 divided by 12, and that is equal to 2.959. And hydrogen is 4.77 divided by 1 to throw out 4.77 again. And oxygen is 37.85 divided by 16, and that is 2.366. And nitrogen is 8.29 divided by 14, and that is 0.591. And also sodium is 13.6 divided by 23, and that will also give 0.591. So we then see that the smallest here is 0.591. So we divide through by 0.591. So here is 0.591 divided by 0.591, and that will give 1. Here is the same, 0.591 divided by 0.591. That is also 1. Then here is 2.366 divided by 0.591, and that is equal to 4.00. And here is 4.77 divided by 0.591, and that is equal to 8.07. And for carbon, it is 2.959 divided by 0.591, and that is equal to 5.00. So rounding them off, here is 5, this place is 8. Then oxygen is 4, nitrogen is 1, and sodium is 1. And therefore, the empirical formula for caproic acid is C5H8O4. Then nitrogen is 1, and then sodium is 1. So this is the empirical formula of caproic acid. Nonetheless, a question said that the molar mass of caproic acid is 169 grams per mole. So this implies that the molecular formula, which is equal to C5 H8 O O4 N Na times a certain number N is equal to 169 gram per mole. So let me continue from this place. This means that, so let's go ahead by doing this. So this is, carbon is 12, so 12 times 5, then plus hydrogen is 1, which is 1 times 8, plus oxygen is 16, which is 16 times 4, plus nitrogen. Nitrogen is 14. So here's 14 plus oxygen. Oxygen is 16. And all of this times N equals 169. So 12 times 5 is 60. Then plus 8 times 1 is 8. And plus 16 times 4 is 64. Plus 14 plus 16 times N equals 169. So 16 plus 8 plus 64 plus 14 plus 16 is equal to 169 N equals 169. So divide through by 169. Here 2 by 169. This and this cancels out. So you see that N is equal to 1. This implies that the molecular formula of monosodium glutamate is equal to the empirical formula of monosodium glutamate, and that is equal to C5H8O4N and then Na.